Hello, everybody, and welcome to this session of Cloud Lunch and Learn. Today we have Javier Villegas doing high availability and disaster recovery in SQL Server and Azure SQL. If you remember last week, Javier was with us and talking about SQL Server and Azure SQL and how to manage it and monitor and work with it. And this week he's going to talk about how we build a resilient and highly available environment. So with no further ado, I will kick it off to you, Javier.
All right. Thanks a lot, Dwayne. And once again, thank you for inviting me to present on Cloud Lunch and Learn. Definitely a community that I love. This is my fourth session in 2 years. So I really like to present here. And well, welcome everybody. Today we're gonna be talking a little bit more about Azure SQL and SQL Server, same as last week, but this time we're gonna go through on how to achieve something that is extremely important nowadays, right? Which is high availability and disaster recovery. My name is Javier Villegas. I am from Buenos Aires, Argentina. I work at Mediterranean Shipping Company as IT director in the DBA and BI services areas. I've been involved with SQL Server for more than 25 years. I am Microsoft MVP in the data platform category since 2016, and I am also Microsoft certified trainer. I'm also part of the board of advisors for the Azure Data Community, which is the organization that is driven by the community and empowered by Microsoft, that we are trying to, provide guidelines to the Microsoft data platform product team on the different needs related to the data community. I'm also a technical speaker. I'm part of a bunch of events, and when you see my name, most probably I'm going to be talking about SQL Server or something related to that. I'm one of the organizer of our local community down here called SQL Argentina. I also put here my contact information, email address, Twitter, LinkedIn, and my blog. Feel free to reach me at any time if you want to network with me. If you have any questions about this presentation, don't doubt, just reach me. All right. We saw this slide last week, but I love to put in context about what we're gonna be talking today, right? And this is mainly about SQL Server and at the top of it, Azure SQL. We cover all the different components of Azure SQL last week, right? So, but today we're gonna be mainly focusing on how to achieve high availability and disaster recovery for three of the components that we will discuss, right? Azure SQL Virtual Machines, right? Managed Instance, and Azure SQL Database. For some of this, Microsoft provides us with certain service level agreement, meaning uptime by contract, right? So when we provision one of these virtual machines or one of these services, by default, just by doing nothing more than deploy them, we have certain level of availability, right? Let's see, for some cases, on how to increase that, because we are all aware that there are certain scenarios in where we cannot, or our business cannot, afford any downtime, even if it is minimal, right? Even be prepared for natural disasters and those kind of things. All right, so let's define a little bit what is high availability, and then we will compare, because some people believe that high availability and disaster recovery are the same thing. In fact, they are not. They are tied, but they are not exactly the same, right? So for a system to be highly available is that it has to operate all the time on as close to 100% of the time, right? So definitely, the intention is to have everything working constantly, no matter what, right? And try to accomplish full uptime. To do that, right, we have to come up with certain type of solution. And the most important thing is that we have to consider that every single component of our solution, in this case, Azure SQL, has to be redundant. So every possible component that may fail, right, we have to consider to duplicate it and have a strategy for that. Example for those things. If I have a disk, right, a local disk, a local drive, well, I have to configure it as a mirror, right? You have another disk writing on the same information. So eventually, if one of those disks have a problem, the other one can take the workload without any service interruption, right? Not only the disk, sometimes, or in most of the cases, the storage system is a remote hardware, right? So to connect our server to the storage, we need, a different piece of hardware and also cables to connect. And there are cases in where those network cards or those cables may also fail. So for those cases, we also have to configure at least two of them, right? So two pieces of cables with the network connection, etc. So in case something goes wrong with one of them, we need to, the other one could take the responsibility for the other. At network level, right, we can also have a switch in where our SQL Server hardware is connected to, right? That switch can fail, and that failure can also make that our service goes down, right? So in some of the cases, also we have to duplicate this switch as well. And there are some cases in where we also have to duplicate the whole hardware, the server, right? So we have our principal server, the one in where we do the read and write of our SQL transactions, our workload, and then there is another one configured in some sort of standby mode that, again, in an event of failure, even of the whole server, the other one can take, the action and replace the other one with no problem and fairly quickly. Right? I will say that several years ago, this was a hard conversation that the technical people had with the management, right? And the point is that, to be able to have a highly available environment, you have to buy different type of hardware, right? Twice, and have it as a standby mode, let's say. So you have to invest money, spend. For some people is spend, for other one is invest, right? But this conversation was really hard, because why I have to pay double? Will I have the double of performance for my workload? And the answer for that is no. You're going to have exactly the same performance, because this is not to scale the solution and have more horsepower. It's to have a highly available environment, right? But then nowadays, this conversation is kind of already accepted, because everybody understand that if I have my mission critical decision maker system down for hours, especially nowadays when we have services that are servicing the whole world, right? We may lose a lot of money while the system is down, right? Something also important to consider is that when we are designing a new environment, right, a new solution, right, we have to consider the high availability and disaster recovery from day one, right? So it's way more easy, absolutely more easy, if we design the solution with HA and DR in mind from day one, than if we have just a separate server there and we say, oh, now I need to do something to accomplish HADR for an existing environment, right? So, those are the things that will make our environment highly available. There is also something to consider, because, and I've seen this multiple times, we may have our SQL Server environment fully redundant, highly available, etc. Right? So in a matter of a problem, and we have to, jump to the other environment, the one that is, let's say, in a standby mode, right? Everything is fine in a matter of seconds, but then we also have all the applications and all the ecosystem that connects to that environment, right? We won't be discussing that today, right? Because it's out of the scope, but definitely it's something extremely important, because we may have our SQL Server up and running, right? No matter what. But if the application servers, the web servers, whatever needs to be connected, the clients need to be connected, are not capable of handling the high availability solution, then we're gonna be in trouble. So what we just said till now also applies for everything, right? If we have a web server, an application server, or something like that, we may have hardware problems, right? So we may also need to duplicate all the pieces that may fail and have redundant scenarios for all of that. So how do we measure the high availability, right? That's let's go a little bit technical on see how we can say, hi, my system is highly available. Okay, how do you measure your high availability, right? So in an ideal world, right, we can say that the system is 100% operational, or that never fails, right? Well, that's never happened, right? And this is not even possible to accomplish. Consider that, sometime you may have to apply updates to your operating system, to your SQL Server, those kind of things, and there's gonna be, a downtime at least a minimum downtime, right? Give me 1 second. Yeah, sorry about that. Okay, so how do we measure this? Right? So the availability is the number of minutes that our environment is available minus all the minutes or the number of minutes that the system is down, right? So that's gonna be 99 something, and we're gonna go deeper in a minute. But then there are other metrics that are quite important to understand our environment and actually to eventually predict when it's going to be the next failure, right? So there is this value called mean time between failures, MTBF, right? When it's how often, right, or the amount of time, hopefully years, between one failure and the other one. Right? So we know that maybe every 6 months we may expect one failure. Right? So those are things that we need to document. So we know the mean time between failures. Right? Then, we need to know when our system is down for how long the system is down. Right? So that is the mean downtime. Then there is another important value that we need to know, that is the recovery time objective, RTO, right? This is for, let's say, we have an expected or unexpected outage of our system. We need to know for how long it's going to take us, right, to recover the environment. 1 minute, 10 minutes, 1 hour, right? It's important to have that number in mind as well. So how do we measure, right? Then we have this concept of service level agreement that in several cases, I would say most of them, if you are a service provider and you sign a contract with your clients, you have to guarantee certain service level agreement or SLA, right? And normally the SLA is measured in nines, right? 99.9, 3 nines, 4 nines, 5 nines, and so on, right? And just to give you an idea, if we say that our environment has 3 nines, meaning 99.9% of the time is up, right? That means that we have 8 hours, 40 and almost 46 minutes of total downtime in a year, right? So imagine that in the complete year, we may have our system not available for 8 hours and 46 minutes. If we have an SLA of 4 nines, we have only 52 minutes and a half per year, right? Just imagine those numbers in your own environment. And then if we go a little bit further with 5 nines, it's only 5 minutes and 16 seconds, right? So, of course, if we keep adding nines to our SLA, right, is less amount of times. And of course, we may have to, let's say, this concept of duplicating everything and have a standby system. Well, most probably it's going to be more sophisticated. Mm. So, as a quick summary for this, right, to achieve high availability, we need to design our environment having high availability in mind from day one, right? Extremely important, right? So if we have this in mind when we are building the system, HA in mind, that's going to be way more easy. Test our environment. What does it mean? When we have the possibility, right, let's test if in reality all these solutions that we design considering high availability works, right? Let's try to remove one disk, shut down one network card, unplug one network cable, and even shut down unplugging one of the servers to see how our environment reacts to those situations, right? The goal again is automatically in a matter of seconds being up and running again without any further trouble, right? So test your HA solution every so often, and also monitor everything, right? It's extremely important that you check how your environment is doing, right? Because eventually knowing how what you are dealing with will also allow you to eventually predict when the next failure could happen, right? So that's extremely important. Now let's move a little bit to disaster recovery and see how, let's say, this can be achieved, right? So if we go backwards just a couple of minutes, right, we were talking about high availability, right? Duplicating all the hardware, including the server itself, right? But what about if that server is with duplicate hardware, duplicate everything, including duplicating the power source with the cooling, everything is on a data center which is in a location which has, let's say, a natural disaster like a hurricane, an earthquake, or something like that, right? Doesn't matter if you have 2 servers, 3 servers, 4 servers, and 2 power generators, right? Your environment will definitely go down, right? So in a matter of a major disaster, we also have to consider having the same setup, right, on a remote location, right? It could be several miles away, in a different state, in a different country, right? But we may have to set up a mirror, let's say, of the overall environment somewhere else, right? In case, again, a major disaster happens. And let me tell you that in my years of experience working with SQL Server, I suffered 2 earthquakes in New Zealand and in Chile, right? In where we had to go through the disaster recovery plan and putting everything up and running on the disaster recovery scenario, right? So it could happen, right? So there are several best practices in terms of achieve high availability and disaster recovery, right? So we can go through all of them, but it's important to consider that in order to have a highly available environment with HA and DR, we have to duplicate everything, even the overall data center in a remote location. Again, there are certain businesses that cannot afford any downtime, even if it is minimal or even if there is a major disaster. Right? So Note something interesting. Up to this point, I didn't mention SQL backups, right? Or taking any kind of backups, right? This is something that I will say is part of an HADR scenario, right? But even if it is not, it's part of our daily task as database administrator, right? We have to make sure that we take the backups in the right way, properly, meaning full backups, differential, transactional. There are multiple schemas or approach to do it, right? And of course that we store those backups properly, right? So if we store the backups on the same server, right? If the server goes smoke, well, we lose the backups as well. If we store the backups on the same location, if there is a major disaster, we're gonna lose the source system as well as the backup. So as part of the best practices, we need to physically store those backups also in a remote location, right? It's also extremely important to test those backups. So randomly or on a schedule, or you define it, right? Test that those backups that we are taking from the source systems, we can properly use them by restoring them and having access to the data, right? So then if we start going a step further, so we have the duplicate components to achieve high availability. We have a disaster recovery solution in place, having a different data center or an Azure Region in standby mode, right? So how do we make this happen, the magic happen, to have the data synchronized, let's say? And there are certain approaches that we're going to go through from this point on, right? Some of them are, I will say, not totally intended to be the solution for an HADR scenario, but I will let you go through because in some cases it may fit, right? One of those features, which is in fact part of SQL Server since many years ago, is SQL replication, right? And there are certain pros and cons on using SQL replication. First of all, this is a solution that is mainly intended to replicate data, right? Not the overall system, right? So we can have certain tables within a user database that we can replicate to one or multiple local or remote environment, right? There are several, as I said, benefits, like, for example, the SQL servers could be on different version, but is in the cons column, we can say that, okay, it's kind of hard to handle very large databases, right? It's difficult to maintain if there is a problem, so to do any troubleshooting, it's going to be hard. And in a case of a problem that we have to switch from system A to system B, this is a manual process that's going to require someone to take action, right? Then, several years ago, Microsoft introduced a technology called database mirroring, right? Which was in use for several years, several SQL Server versions, actually, but now is discontinued because it was replaced by another one that we will cover in more details in a minute, right? With database mirroring, we had also some pros and cons. In the pros section, we can say that now we can accomplish automatic failover. That means if there is a problem on the source system, automatically detect that problem and switch the operation to the other server. Right? And in this case, it's not like in SQL replication that you had to set up per table, per database. You just select your whole database and put it in there. Quite easy to set up. And if in the case that we have to do a failover, right, the process was quite fast. There were several cons, right? One of them that for database mirroring, this can have only two servers, right? The primary and the mirror. And, it was there on in a standby mode without being able to access the data on the mirror replica, right? And, this feature was replaced in SQL Server 2012 by a new feature that we are still using today, which is always on high availability and availability groups, right? Always on availability groups, right? This feature has evolved till something really first class to do different kind of synchronization. We will cover it, as I said, in details in a minute. There are also others techniques, right? Like, for example, SQL Server log shipping, right? So this is the concept of shipping the transaction log backup files to multiple secondaries and applying those transaction logs to the copies in standby mode, right? And, as a pros, we can do this to multiple servers, right? In this case, the secondary replica are also in kind of read-only mode. So eventually we can access the data that is located in the primary on the secondary, but as read-only, right? Same as replication, hard to maintain, meaning troubleshoot, all those kind of things, and also requires a manual failover. Right? Those are some techniques that are SQL Server features to try to accomplish HADR. Right? Maybe SQL replication is not totally intended, it's more to distribute data, but eventually, in some cases, it was used to accomplish HADR. Right? And then if we talk about high availability, we can also discuss about a feature which is failover cluster, right? In this case, a failover cluster, which is actually available since many years ago, right? This is actually a feature that is part of Windows Server, right? And it gives you the possibility of having two or more servers, right, sharing the same storage, right? Meaning that all of them, let's say only two, the active and the passive, can access the storage at the same time. But only one of them has the possibility or the visibility to the storage on a given time, right? So the one that is designed as the active node, right, will access the disk. And we will install SQL Server in a different way, telling it that this is not a regular installation or a regular setup. This is a failover cluster, right? Then on the passive node, we also have to install SQL Server on a different mode, which is adding node to the existing cluster. And how this works, right? We have the SQL Server services on the active node accessing the files on the shared storage, right? But if something happens to the active node, you name it. It could be applying patchet, it could be lost power, it could be an unexpected reboot, anything. It's automatically initiate the process of failover. What is a failover? Well, basically switching the roles, right? The one that is active and the one that had the problem, right, will basically release the disk. The other node, of course, stop the SQL Server services, right? And the other node will have SQL Server in kind of standby mode, right? We'll start seeing the disk, right? And we'll come up with the SQL Server service and the same disk. So that means that you are not going to lose any data, right? Because you are using the same storage, the same disk than the other node, right? And this is also quite interesting because you don't have to, even if there are different servers, right? You don't have to go to all your connections, your clients, and change the connection string from server 1 to server 2, right? And this is because the failover solution, the SQL cluster failover solutions, give you also the possibility of having one virtual name and a virtual IP address. That means that you won't be connecting here in this example to VM01 or VM02. You will be connecting to that virtual name, in this case, SQL FCI01. So it doesn't matter which is the active node and which is the passive node, right? You will always be connecting to that same solution, right? That virtual name and virtual IP address. So if we go into some of the details regarding to how to configure a Windows cluster, right? You have within Windows the nodes that you have in your solution, in this case, 2 nodes, right? Then after you install SQL Server, telling that in the setup process that is a cluster, you will have all the available storage with a virtual name and a virtual IP address, and also the SQL Server services. And from here, right, you can, eventually do a manual failover, right? Switch the role active, passive from here, or, you can also reboot the server, and automatically all these resources will be owned by the other node, right? So here we have the disk. This is interesting because we can accomplish high availability, right? But what about if we need to do also disaster recovery, right? We cannot share the storage. There are certain solutions that are replicating the storage, let's say, as a background task, but it's not, let's say, part of SQL Server. This is an external solution, right? So how do we accomplish that with what we have, which is SQL Server? Okay, remember when I was talking about database mirroring, right? That was replaced by a feature called always on availability group, right? This always on availability group feature basically allows you to replicate, right, your user databases, one or more, right, to multiple servers, right? And there are two ways of doing this synchronization. One way is synchronous, and the other one is asynchronous, right? The synchronous mode, basically, you can have, let's say, two nodes sharing the same storage, two different storage, and, behind the scenes, when you initiate a transaction in one of your SQL servers, right? You won't get the acknowledge until the transaction is committed into both nodes, right? So that is synchronous, and that guarantee that you won't have any data loss in the situation that one of the two nodes goes down, right? This solution, the synchronous one, is mainly intended to accomplish HA, because you should have the both systems on a highly speed network, right? So one close to each other. But if you have a server which is located in a remote data center, right, you have a network connection that most probably will have certain latency, right? And for that, you cannot use the synchronous solution, because if it has to go and commit the transaction on a system that is remote with all this network latency, you will have certain performance problems. For that case, you have to use availability group configured as asynchronous mode. That means that your transaction will be committed to the primary, right? And as a background task, it will synchronize to the remote server or servers. You can have multiple, right? What is the benefit? Well, first of all, you are synchronizing the data, right? You won't be affecting the performance, right? And what could be the problem? Well, there's maybe eventually some data lost, right? Because again, this is an asynchronous process. So you can combine, for example, a shared storage failover cluster to achieve high availability with always on availability group to synchronize the primary, right, with a secondary which could be located on a different region. So you can have, I believe that in 2019, up to 16 replicas, right, sharing the availability group. Availability group can contain multiple user databases. One of the replicas will be the primary and the rest will be the secondary, right? The primary is always the replica in where you can do read and writes, right? The secondaries are the ones that are receiving the synchronization, so saving the data as well, either in synchronous or asynchronous mode, right? But they are not write replicas. They are read-only replicas. So eventually you can configure one of the replicas or more than one of the replicas to be read-only secondary replica. That means that if you go to your primary database and you do an insert of a row in a specific table, right, you will be able to see that row. In the secondary server, you will be able to do a select, right, and see it right away, right? But you won't be able to do update, insert, or delete on the read-only replica, because as the name stands, is read-only, right? But even though this is a solution that eventually, if the primary replica fails, one of the secondary can take the role of being the new primary. And at the same time, while it is a secondary replica, it can act as, a source of any of your read-only workload, like, for example, reporting services, data warehouse, or any source that only requires select for the data, so read of the data, right? So at the same time, besides accomplishing high availability and disaster recovery, you will be removing that read-only workload from the primary and moving it to one of the secondary. right? That will also help you to have better performance. All right, as we said earlier, we have two modes in availability groups, right? Asynchronous, right, which will ship the changes in a background task without affecting the performance on the primary, and then the synchronous if you want to make sure that there is no data loss, right, at all. And then there are two types of failovers, right? One is when you plan to do a failover. Let's say that you are testing the solution, or you need to, let's say, apply Windows and SQL patches to your primary, and you have to failover to any of the other replicas, right? You can plan it, and you can do it from Management Studio quite easily. Just do this process of failover, and of course, there's not going to be any data lost, right? And then, the automatic failover, right? That the automatic failover only works for replicas that are configured as synchronous mode, right? Remember this one, that when you have a transaction, is gonna commit it into both of replicas before giving you the acknowledge to move on, right? This way, it guarantees that there are no data loss between one and the other, and the data is exactly the same, right? So this is an automatic failover. And same as when we discuss about failover, shared storage failover cluster, right? The overall always-on availability group solution, you won't have to go and change the connection string every time that you do the failover. And this is because there is this concept of availability group listener, right? Which again is a virtual name and a virtual IP address, right? That doesn't matter which of the replica is the primary and which is the secondary, right? You will always be connected to the listener, right? So even if you have to failover from server A to server B, right, you always be connected to the listener, right? So how do we see this in SQL, right? Well, in Management Studio, we will see that we have availability group, in this case, HE001, with, in this case, 3 replicas, server 1, 2, and 3. The primary is server 1 in this case, and there are 2 secondaries. And then the availability group has 3 user databases, right? MyDB01, 02, and 03. And we have the listener, right? HEList01, which all the clients are using this in the connection string, right? So then if we start discussing a little bit more about Azure, right? Do we have to worry about all this if we go in Azure? And the answer is yes, right? It could be a natural disaster in an Azure region, in an Azure data center, which can bring the whole thing down. And if we don't have our disaster recovery solution, right, then we will lose the service, right? So what Microsoft gives us, for example, if we're talking about SQL virtual machines, right? Initially, the approach was, okay, we have what they call availability set, right? With a concept of full domains. You know that Microsoft had to apply patches to their system and do maintenance, right, in background, to be able for us to use all those services, right? So this concept of full domain, when we are creating our virtual machines, we have to tell it, okay, this virtual machine will go to the availability set 1, and this other virtual machine will go to the availability set 2, and this one to the number 3. And why we have to do that? Well, Microsoft guarantee you that they won't be doing any maintenance at the same time in different fault domains, right? So if they are working on something, they're going to be working on one of the fault domains. So eventually, if you have a problem with your server going down, right, because of, again, anything that Microsoft is doing behind the scenes, you know that there are other availability sets that won't be affected by that operation. Right? That's availability set. And, for example, you can create your nodes or your virtual machines in different fault domains. Then there is a new concept, or a more recent concept, called availability zones, right? That is for a given Azure region, right? These regions are the ones that are distributed all around the world, right? For each of the regions, they can have up to 3 availability zones. What are availability zones? Well, basically, separated buildings interconnected with redundant high-speed network, right? So they have independent power source on each of the regions, etc. So whatever could happen in one region, maybe it's only affecting one zone. And again, when you create your virtual machines, right, you can define on which zone it could be, right? In the most important Azure regions, you can have up to 3 availability zones. And then, after we define which availability set or availability zone we deploy our virtual machine, but at the top of it, we can use all the things that we've been discussing. Always on availability group, with also shared storage failover cluster, log shipping, of course, backup and restore. And then there is a solution called Azure Site Recovery, right? ASR. Basically, this ASR, what it does is it takes snapshots of the virtual machine every 1 hour, 2 hours, 4 hours, something like that. And then eventually, if something happens, you can let's say use those snapshots to recover your virtual machine, right? This is interesting, but for SQL Server, it doesn't apply much, because, if you have a virtual machine up and running with SQL Server, and a lot of activity, some of that, SQL Server memory can be used, or those cache can be in use, so you don't have the data physically in the disk, right? So, if you take a snapshot, you're going to take a snapshot of the virtual machine and the disk, but not on the memory, right? So most probably, when you try to reuse those snapshots, you will have consistency errors in your user databases. That is why it's not intended for this kind of SQL solution, right? The main recommendation from Microsoft of how to accomplish HADR for SQL virtual machine is using always-on availability group, right? So here I have some comparisons on, failover cluster and availability groups. The interesting thing is that you can combine them to, get additional HADR and, those additional lines that we discussed at the beginning, right? Something also quite interesting is that Microsoft announced SQL Server 2022 last year, and they're getting into this approach of the hybrid data services. That means that as part of 2022, there's going to be the possibility of combining in the same availability group, right, SQL Server 2022 with Azure SQL Managed Instance and have the same thing that we discussed till now, right, in there. So the SQL Server on-premise or the virtual machine could be the primary replica, read-write, while the copy in managed instance is the secondary read-only. And of course, taking advantage of everything that we said, like, for example, the asynchronous replication plus the read-only workload, meaning the managed instance could be the source for our BI repositories or reporting repository, right? And even more interesting, we're going to be able to do failover, meaning switching the roles, right? Now, if we do the failover, the primary could be the replica standing on the managed instance, while the secondary and the one that gets the replication is the one in SQL Server 2022. So stay tuned, because soon we're going to have the first public community technology preview version, CTP version, right? So soon we're going to be able to play with it, right? So now let's go and see all this in action. All right, let me show you what I have here. Basically, what I will show you is two virtual machines, right, configured with always-on availability group in synchronous mode. That means that every virtual machine, most of the virtual machines, they have their own SQL Server installed, as well as their own storage, their own disk, right? So what do we have here? So I am connected to one of my virtual machines, right? VM N001, right? And this one right now is secondary. Then I have only one database called test in this case, and at the moment I don't have a listener available here, because again it's part of a demo. If I go to the other node, right, node 02, and I open Management Studio, I can either open it from here or go back to my other node and connect. Right. So in my node number 2, if I go to availability group, I see, of course, the same availability group, right? But note that here the role is primary, while in this one the role is secondary. So I have, of course, the same database here called test. If I go to my primary and I go here and I will create one table, right? I do use test, go, and then I will do select start from this options, for example, and I will send this to a new table into demo table. So if I go here, now I have my demo table, right? This is my read-write replica, right? So I have 100 rows. Let's go to my secondary node right now. So if I go to my secondary node, right, I will be able to, let's say, do the select, see the same amount of rows, right? So we have it in replication. If I go back to my primary node, what I'm going to do right now is I'm going to delete a few rows, right? Delete from demo table where object ID less than 10. Right? If I go here, I'm able to delete. I just delete 6 rows. I go to my main table, I do select. Now I see that we have 94 rows. And if I go again to my secondary and I do the select, I see the same 94 rows, right? And let's say that eventually in my read-only secondary, I want to, let's say, delete my table. One row or the whole thing, right? I'm gonna get an ugly message say, fail to update because the database is read-only. Right? So at this moment, we cannot do anything besides select on my database. All right, so let's say that my primary, which is the node number 2, we need to apply Windows patches or do something, right? And we have to initiate the failover process. How do we do it? We either go to the server 2 and reboot it, and automatically will switch. And this is because the replica is configured as synchronous, right? But what I'm going to do right now is I will go to the availability group and I will initiate a manual failover. So I go here to failover, right? It will tell me, okay, we are ready to do the failover, and there's not going to be any data loss because you are configured as synchronous, right? It will ask me to connect to the other node, right? Again, because this is a planned failover. And then we initiate the process of switching the roles. The one that is primary is going to be the secondary, and the one that is secondary is going to be the new primary, right? So now number 2, which used to be the primary, now is secondary, and node number 1 is the new primary. So if I go to node number 2, and now I want to delete from my user database, right? Now I will see the error message here because now this one is read-only. And if I go here and I want to delete everything from my table, right? Now I wipe it out. And if I go back to my replica, the table is empty. Right? So again, you are replicating not only this table, right, but you are replicating all your user data. So quite interesting on how to use this. All right, so that was the demo. Again, I leave you the link for the Azure SQL Fundamentals to keep learning about Azure SQL, the overall thing, not only high availability features, but everything related to Azure SQL. And with that, we finish the presentation. Thank you, everybody. And Dwayne, tell me if there are questions or
Yes.
something.
Don't see any questions in the chat, so I think we're good. Great presentation, Javier.
Thanks.
And thanks everybody for attending Cloud Lunch and Learn today. I hope you enjoyed it, and hope to have you back again at a later date, Javier.
All right. Thank you,
Thanks,
Dwayne.
everybody.
Again, thank you, everybody.
Thanks.
Have
Have a great day, everybody.
Bye.